Hello friends, welcome to engineering tutorial. Now we had already started the transistor concept, such as the basic concepts about transistors and the working principle of NPN and PNP type bipolar junction transistor in my previous videos. So here in today's video I decided to demonstrate an application of a transistor circuit, the bipolar junction transistor. So what is one of the important application of a transistor circuit? So basically the most common and important use of the transistor is in the form of an amplifier. What does an amplifier do is that it converts a low energy signal into a high energy signal. So basically it increases or raises the strength of a weak signal into a high energy signal. So here we will understand how a transistor, which configuration of transistors used can be, or how it is connected in the circuit so that it functions as an amplifier. So let's get started. So before we understand how transistor works as an amplifier, we must understand the basic concept. Now a transistor raises the strength of a weak signal. Okay, normally the common emitter and common base configurations are used primarily for voltage amplification, that is, to increase the voltage level of the input signal. For current amplification, the common collector configuration is used, and there is a lot of other things. But today we are going to study how voltage amplification is done. So for that, normally the common emitter and the common base configurations are used. Now the weak signal is applied at the input junction, and the amplified output is taken across the output junction. Now here for demonstration we have used the NPN type BJT, which is connected in common base configuration. We can also use the common emitter configuration. Here for demonstration I have used the common base configuration. Okay, now this is the circuit diagram of the transistor circuit used as an amplifier. So here we have is the NPN type BJT. How do you know that this is NPN type BJT? From this arrowhead, it is directed away. So this is the direction of the emitter current, away from the BJT. If it would have been towards the BJT, it would have been a PNP transistor. So always, whenever a transistor symbol is given, always pay attention to this arrowhead. If it is directed outwards, it's an NPN type BJT. If it's directed inwards, it's a PNP type BJT. So here we have the emitter current directed outwards and the collector and base current directed towards the transistor or the BJT. Now we know that the input junction in the BJT is always forward biased. This is a NPN type BJT. Okay, this one is N, the emitter, N type emitter, P type base, and N type collector. So for forward biasing of the input junction or the emitter base junction, the N type emitter is connected to the negative terminal of this supply voltage, and the P type base is connected to the positive terminal of the supply. And the output junction is reverse biased, or the collector base junction is reverse biased. So the N type collector is connected to the positive end of the supply, and the P type base is connected to the negative end of the supply. So this reverse biases the output collector base junction. Now the input signal, the voltage signal which is to be amplified, is applied at the emitter base junction. Okay, the input junction. Now the forward bias on the input junction, it decreases the resistance of the emitter base junction. Okay, the emitter base junction has very low resistance in the order of ohms, whereas the output junction has very high resistance, the order of several kilo ohms. Okay, now the output voltage, it is taken across this load resistance which is connected to the collector, and it's called as the load resistance RC or the collector resistance RC. It is also of the order of kilo ohms. So this is the circuit diagram. Okay, now another important thing to take care of is that if the input signal is of an alternating type with a let's say a sinusoidal signal it is. So even during the negative peak of the input signal, the emitter base junction should be still forward biased. It means that during the negative peak of the signal, this voltage VEE should be selected in such a way that the emitter base junction of the transistor is always forward biased regardless of the amplitude of the input signal, this input signal. Okay, it should be always greater than 0.7 volt for silicon and 0.3 volt for germanium. Okay, if it's a silicon type transistor, it's 0.7 volt VBE, and if it's a germanium transistor, it's 0.3 volt. So the VEE, this voltage is selected in such a way that this voltage across this emitter base junction is always greater than 0.7 volt for silicon and 0.3 volt for germanium. This is an important thing to take care of. Okay, now the working principle. Okay, we know that the input junction or the input circuit, which is the emitter base junction, it has forward bias. As a result of that, it has very low resistance of the order of ohms, so a few ohms. So if this input signal, if it, let's say, it changes by a very small amount, okay, a very small amount, okay, a few volts, let's say 0.1 or 0.2 volt, okay, if it is, even if it changes by that margin, it will cause a very large change in the emitter current because of the low resistance. So it will cause an appreciable change in the emitter current, which is the input current in this case. Okay, so a small change in voltage produces a significant change in the current, the emitter current. So we know that in a BJT, the emitter current is almost the collector current is almost equal to the emitter current. Only a few amount of electrons in NPN BJT or holes in PNP BJT is lost in the electron hole recombination, which is of the order of few microamperes. So normally the collector current is almost equal to the emitter current, and normally the collector current is 95% of the emitter current. So more or less the emitter and the collector current are the same. So a small change in this input signal causes a significant change in the emitter current or the collector current because they are almost equal. Now this collector current, which is the output current in this case in the common base configuration, it flows through this output resistance, which is selected of the order of a few kilo ohms. Let's say it's 10 kilo ohm. So when this collector current with the order of milliampere flows through this load resistance or collector resistance, it produces an output in the order of several volts. So millivolt input signal, it gets converted into an output signal of the order of volts. So this is how the amplification mechanism or the process of amplification is carried out in a transistor or a BJT circuit, which is used in a circuit. So a small input signal or a weak input signal is applied at the emitter base junction or the input junction of the common base configuration, and because of the properties of the BJT, which is forward bias in the input junction, which has low resistance, a small change in voltage produces a significant change in the emitter current, which is almost equal to the collector current, and it flows through the output load resistance of the order of several kilo ohms and produces a very large output. Okay, a weak signal is converted into a high amplitude signal. Okay, so let us try to understand it in terms of numbers. Okay, let us assume that a 0.1 volt change occurs in the input signal voltage. Okay, a change of 0.1 volt. Now this causes a 1 milliampere change in the emitter current. Okay, the emitter current changes by 1 milliampere because of 0.1 volt change in the input signal voltage, the weak signal. So this change in the emitter current is almost same as that of the collector current. So the collector current also changes by almost equal to 1 milliampere. The collector current is also shows a change of almost close to 1 milliampere. Now this flows through the load resistance RC. Now let that load resistance be 5 kilo ohm. Okay, it is in the order of kilo ohm. So the output voltage is which appears across this load resistance of 5 kilo ohm is 1 milliampere, which is the collector current flowing through the load resistance 5 kilo ohm equal to 5 volt. So here we have converted this 0.1 volt voltage change or signal amplitude change into 5 volt at the output. Okay, so this is how the amplification has taken place. Okay, so this is the mathematical explanation of the amplification of a signal using a bipolar junction transistor. So this is how the practical circuit looks like. Now one of the most common examples of amplification which we use in our day-to-day life is the microphone and loudspeaker arrangement. We speak into the microphone, our voice signal, even though it's of low amplitude, it gets amplified and we hear the amplified version of our voice at the loudspeaker. Okay, so the input voice signal or the audio signal is fed into the microphone gives it to the amplifier block, which amplifies it, and the output is taken and is given to the loudspeaker, which is connected to the amplifier. Now the battery, it provides the required forward bias and reverse bias voltage to the amplifier. So the microphone and the loudspeaker arrangement is one of the most classic examples of amplification of a weak signal. The weak signal is our voice signal, our audio, which is of very low amplitude when we speak into the microphone. But when we hear our voice over the loudspeaker, it's a very high amplitude. Okay, so this is the practical circuit or a practical example of amplification using bipolar junction transistors. So here we have discussed an important application of the transistor or the bipolar junction transistor, how it is used as an amplifier when it's connected in the circuit in a suitable way. So I hope you like this video. So please subscribe my channel Engineering Tutorial for more such videos related to electrical and electronics engineering. Have a great day. Thank you very much.